Hey guys, and welcome to Petrol Ped. Now, as part of the work I do with Michelin as a brand ambassador, I've been making some videos for them showcasing projects that they're involved with that are outside of the scope of just tyres. They do some really interesting stuff, and I'm going to be able to share those videos with you. And the first one I want to share is all about hydrogen. Now, if you've been following the channel for any amount of time, you will probably know that I've got quite strong feelings. I think that the future of automotive propulsion systems is more than just battery electric. I think there is room in that ecosystem for lots of different types of technologies, including hydrogen. These films were made with my good friend Pat from the podcast, much higher production values than my normal channel videos, and I'm delighted to be able to share them with you. So let's learn more about hydrogen.
So let's talk hydrogen. What is it? How do we make it? And then how do we use it in a mobility scenario? Well, hydrogen is the most commonly occurring element in the universe. But to make it, there are a number of ways. About 50% of the hydrogen we use is made in a process called steam methane reforming, where we use natural gas and water to create hydrogen. You can use nuclear power to create either pink or red hydrogen, and there's some really interesting work being done in that field. Or finally, you can use water electrolysis, where we use electricity to split water into its two component parts, hydrogen and oxygen. Now I'm here at Myra, and behind me is a hydrogen fueling station, which is part of their green energy hub that they're just finishing the development of. There are electric car chargers, electric truck chargers, and there's going to be a hydrogen water electrolysis generating station. They're installing a large solar panel farm to power that, so it will all be sustainable and made on site. And that will then enable the various automotive companies that are based here to have access to hydrogen and electricity to deliver sustainable mobility solutions. But how do we use hydrogen in an automotive context? Well, there are two basic ways. First up, you can use it in a very similar way to petrol or diesel in a process of hydrogen combustion with an engine with pistons, and you use the hydrogen to make an explosion that drives the piston and goes through a gearbox and drives the car. Or you can use a hydrogen fuel cell, which basically takes hydrogen and oxygen and through a chemical process creates electricity. And the byproduct of that is water that comes out of the tailpipe. Now yesterday I was in mid-Wales at a company called Riversimple, who've developed a hydrogen fuel cell passenger vehicle. And the work that they're doing is really, really interesting. So let's see how I got on. Hugo.
Hello, Pete.
Great to meet you. How are you?
Very good to meet you.
Now then, I have so many questions I want to ask you, but can we just start with what is Riversimple? Just tell me a little bit about what you're doing here.
Well, Riversimple, we've been developing hydrogen vehicles for the last 20 years. We've been through 5 generations of vehicle in that time. But really, we're a sustainable car company. We're not a hydrogen car company.
Okay.
We're focused on delivering truly sustainable vehicles. Won't happen overnight. It's going to take us some years, but we have a roadmap to getting there. So we are focused on building cars for everyday use for everybody. We're not at the Tesla end of the market, and it's a huge gaping hole in the market because cars are becoming increasingly unaffordable at the bottom end.
So tell me a bit more about how it works. Where do we start with that?
The great advantage we have at Riversimple really is a clean sheet of paper.
Yeah.
I admire hugely what the auto industry is doing in making hydrogen work in their model. But essentially you're trying to persuade hydrogen to behave like petrol and a fuel cell to behave like an engine.
Yeah.
And it really doesn't do it very well. So they've been throwing billions, literally, at trying to improve the technology way beyond the state of the art to make it work in a conventional model. The only advantage we have as a startup, I can assure you, is a clean sheet of paper. So we have no legacy constraints, no established manufacturing strategy, business model or anything. And we've designed the entire company around the characteristics of hydrogen and the needs of the 21st century. The fuel cell you'll see over there is only 10 kilowatts. That is the prime mover.
Should we go and have a look?
Yes, absolutely.
So fuel cell. Now I have driven a fuel cell car before. They're tiny, aren't they, really?
Yes, and that's quite a large fuel cell for 10 kilowatts. There are plenty available that are less than half that size. And I mean, 10 kilowatts, to put in perspective, will just about power 3 domestic kettles.
Okay.
That's 3 kilowatts a kettle. So, and that is the prime mover. That will keep the car moving at a steady state of speed of 60 miles an hour. That powers electric motors in the wheels, and they are also the primary brakes, and they charge a bank of supercapacitors. There are some supercapacitors.
Wow.
Don't touch.
No, I noticed the danger high voltage and the big box. So
Indeed.
this is quite a different architecture. Most people will be familiar with a battery in an electric car.
Yes. A supercapacitor has no chemical reaction. It is just storing static electricity. And consequently, it can happen very quickly. We can actually throw 4,000 amps at this bank of supercaps.
Wow.
We only throw about 600 amps at it, and it's got a cycle life of over 1 million cycles, so 100 times that of a battery.
Wow. Now, I know you partner with Michelin, and I've noticed on this tiny wheel, Michelin tyre.
Yes.
So can you tell us a bit about that? And also, you talk about a motor on each wheel. Maybe we could go and have a look at that. 'Cause
Absolutely. Well,
those wheels are, the thinnest wheels was that 115/80 R15s.
this is a tyre that Michelin designed for the VW XL1, their super efficient car. They made 300 of them. And it's a very narrow tyre. It's not that we've got no grip. We just got a very light car. It's only 660 kilos, our car.
660 kilos. Well, we need to find out how you've done that as well. Wow.
So with that vehicle weight, we have perfectly normal contact pressure and normal levels of grip with a much narrower tyre. Wow. So it's the perfect tyre for us, for this car.
Before we leave, I guess that's the hydrogen tank. Right?
That's the hydrogen tank, and that's only 350 bar, 350 atmospheres. It only stores...
Wow. What's that in PSI? That's a lot.
That's about 5,000 PSI.
Wow.
But to put it in perspective, and that's what's being used in trains, buses, trucks and things like that that are running on hydrogen. This is the electric motor. Now we've got motors in all 4 wheels. And as I was saying, these are our primary brakes.
Yep.
And they charge that bank of supercapacitors. The supercapacitors provide 80% of the power when you accelerate. In something like a Prius, you'll recover, in a single braking event, you can recover about 10% of the kinetic energy of the car into the battery. In our car, we can recover 55% of the kinetic energy into the supercaps. And that allows us to size the fuel cell simply for that constant demand. So this is the breakthrough in any of energy efficiency and commercial viability with these cars is really at the level of the system. It's the way in which all the components relate and interact.
Wow. It's so exciting.
The closest road car I've ever driven to this is an old 1960s Elan. It does feel, and it doesn't have the same top speed.
No.
It's got very similar acceleration to 60, slightly better from 40 to 60.
Yeah.
And it's got the very similar vehicle dynamics. So there's no power assisted braking, no power assisted steering. It's a very direct and engaging feel. It does feel different to most modern cars, but it is definitely a driver's car. So I'll show you here the motor and brakes in some detail. This is the electric motor.
Yeah.
And there's 4 of these.
That's the motor.
That's the motor, one on each wheel. So inside that 3.5-inch width, we've got the wheel spokes, the electric motor, the suspension upright and pickups, and the brakes, all inside that 3.5-inch profile.
Wow, okay. Now you're blowing my mind, Hugo, far too much. But if we're talking about lightweight, can we have a chat about your use of carbon fibre? I can see some carbon in there.
Yes.
And it's obviously got a carbon tub. First of all, carbon fibre is always just a work of art, but we're familiar nowadays with supercars having carbon tubs for weight saving and torsional rigidity and so on. What are the main benefits for you? I'm guessing obviously weight is a huge thing. I'm still getting over the 660 kilo weight. That's ridiculous. So and also just where do you get them made, and just tell us a bit more about these, because I think it's
so
fascinating.
weight is one very big factor for us. And actually, contrary to popular opinion, the lighter the car is, the easier it is to make safe, because you've got to manage less kinetic energy in the accident than if it's heavy. Carbon fibre and composite materials generally, the broad spectrum of all the materials that we work with, you see the carbon, but there's other materials involved, gives you a much richer palette and can absorb more energy per unit mass than a metal car can. So that in itself is helpful. You're right that supercars probably have more of a focus on rigidity, but we have a big focus on the vehicle dynamics. We want it to be a fun car to drive, and rigidity, even at low speed and with a low powered car, is absolutely critical to really having good vehicle dynamics. Having said that, this is so rigid that I think it's more than we would need just for that, and it's really the crashworthiness that we're focused on. The other thing that is very important about composite materials is that the minimum scale of production is about 100 times lower than metal. We're selling the service of the vehicle. We keep it on our balance sheet right through to end of life, and the price to the customer isn't driven by the build cost, but by the lifetime cost of the car.
Wow. So when you said before you had a clean sheet of paper, it wasn't just the making the car that you had no kind of constraints. Even the ownership of the car and the ownership model's a different way of thinking.
Absolutely. So we will offer the cars to customers under typically a 3-year contract, much like a lease or a PCP, but it is not one of those. We call it mobility as a service, but it's defined differently by different people. In our case, the customer would take a contract with a fixed monthly direct debit for having the use of the car, and a mileage rate on top of that, like a usage rate on a phone. And that is all your costs included. It includes not just the maintenance and tyres and insurance, it also includes fuel, most importantly.
See, when I came here, I thought, okay, I'm going to learn about hydrogen and the new things about hydrogen in a car. But actually what you're doing here is far more than that. It's not just the powertrain of the car. It's the design architecture of the car. It's the ownership philosophy. It's the business model that you guys are running. And that, for me, is what I find really interesting. Well, they say the proof of the pudding is in the eating. And in this case, the proof will be in the driving.
Absolutely.
Can I have a go?
Of course you can.
Wow, they're so dinky. I know you've got a few in the workshop there, but out in the daylight, you can start to see the details on them. I love these louvres here, and then the covered rear wheels. It looks aerodynamic.
Yes.
Stood still.
Well, the spats make a measurable difference in the wind tunnel to the aerodynamic losses, and you can see the underbody is completely clean. I mean, it's absolutely clean.
That's a cool latch and just mechanism.
Well, that is copied from a 1948 Bristol, and in fact the rubber comes from the Bristol Owners Club. But it's the most aerodynamic door handle you can get, and it requires no electronic gizmos. It can't fail in an accident. It's absolutely ideal.
I love there's so many nods to historic motorsport in this car. Now I'm 6'3".
I'm sure you'll fit.
Do you reckon? But, squeeze in. Oh yeah, loads of space.
It has a heater, it has demist on the windscreen, it has wipers, all the things you need, but no extra frills.
No.
And by doing so, you can build a car that's simpler, it's lighter. There's no component that's more reliable than one that isn't there. Or lighter.
Oh yeah, indeed.
And it does mean also that you can then put more cost into the bits you do have.
Yeah.
So you can have higher quality, by having fewer components, they can all be higher quality.
Yeah. Should we go for a drive?
Absolutely.
I just want to get driving. So just the turn of the key, turn on.
Yes.
So, I mean, this car you said was all about driving. The instant thing is I can feel it's light. The steering's got a lovely feel to it. It's very direct, your inputs are straight away translated into the way the car moves on the road.
Absolutely, yes.
And then, so talk about the partnership with Michelin. So we've got these Michelin tyres on. They are the narrowest tyres of any road car I've ever driven, I think.
No other manufacturer makes a suitable tyre.
Yeah.
In fact, theoretically, the Citroen 2CV tyre would fit onto our wheels and in our wheel arch, but it wouldn't be a low rolling resistance tyre.
Yeah.
And it'd be much heavier too.
Yeah.
So it's not only is low rolling resistance, it's also a lightweight tyre.
So easily just sat here now doing 50 miles an hour with the flow of traffic. It's cool.
And if you floor it, you'll get to 60 quite quickly. That's actually a bit overreading. And if you keep your foot flat,
Yeah.
it just won't go faster.
Oh, I see. Yeah. But that now feels pretty rapid, to be fair. And
Yeah.
now we're going green. So I'm now on the brake, feeding energy back into the supercaps.
Absolutely, yes.
So use case wise, this is the perfect second car. The run to the shops. What's your view on the kind of typical Riversimple customer?
Well, it's important to point out that this is an entry point for the company and the fuel vector and the technology into the market. It's not where we aim to end up. So we've got other cars on the books. We'll build a four-door family car, but there's no point in doing so while there's no hydrogen network.
Yeah.
So this car is designed specifically for local use.
Yeah.
And we believe that that's a very considerable market. There's over 3 million cars in the UK
Yep.
that operate in a 25-mile radius.
I've just found today fascinating, and you said it was a driver's fun car, and it's a lovely nippy little thing. Performance is great. I mean, you might think, oh, it only does 60 miles an hour, it's not going to be fun to drive. That's just not the case at all.
No.
It zips along.
Take it on a country road. There's very few things that will beat it.
Yeah, exactly. But Hugo, I've enjoyed today. Thank you so much for your time and for sharing your obvious passion about Riversimple and the work that you and your team are doing. That little Raza was such fun to drive, and I was hugely impressed by the work being done at Riversimple. So much innovation from the design of the car, but also the ownership experience, the business model, really pushing the boundaries. But here at Myra, there's a company called Viratech, and they're doing some really cool things with fuel cell technology. So I reckon the Taycan should be charged by now, and we're off to meet Matt from Viratech to find out more. Matt.
Hi, how are we
Good to
doing?
meet you. How are you?
Pleasure. Very good, very good.
Well, all I can say is, what a thing.
Do you like it?
It's absolutely beautiful. I want to know all about the car, but I also want to know about Viratech. Tell me more.
Viratech was founded around 3 years ago, 3 years in November, with a focus on developing and providing enabling technologies for hydrogen powertrain. And what that really means is all of the parts that you need in a vehicle that enable you to build a lightweight hydrogen vehicle. And we formed out Procali around this concept of mass efficiency, volumetric efficiency, and that's what you see here. So styled by our friends Pininfarina, 1,000 horsepower, 1,000 newton meters, 1,000 kilos. So as something to demonstrate this lightweighting ethos and this ability to produce really mass efficient fuel cell powertrains is at Procali. And of course, when you take that forwards to HGV and light commercial vehicle, what we're really saying here is mass equivalence with internal combustion. So the vehicle doesn't get any heavier, the payload capacity stays the same.
So we can't drive this though, sadly, today.
Not today, I'm afraid.
But we can find out more about what you're doing.
Absolutely.
Should we go and do that? Because
I'd love to show you around.
I'm interested to find out more, but that's just a thing of great beauty.
Thank you very much, we're very proud of it.
This is where the magic happens.
It is.
I love a workshop.
They're nice, aren't they?
They are. There's loads of things I want to talk about. So let me start up. the policymakers of the world would let us believe that the future is purely battery electric. And I've never thought that way, and I'm sure you don't.
No, I don't. And I think it's a really interesting point, because to solve the problems that we have, you're going to need a whole smorgasbord of options to go at. You're not going to do it with just one thing. And hydrogen is an element that allows us to solve a chunk of problems that you can't solve with just battery or retaining combustion or any of those things. So for me, it's a really useful tool that we can use to solve all of the problems that we've got going forward.
So what kind of applications are we talking about, and where does your technology sit and fix those problems?
For us, we really see it as applications where you need lots of power, so you need to be able to deploy lots of energy, and you need to be able to do it with a small impact or no impact on the vehicle mass. So when you look at something like a heavy goods vehicle, if you are running a heavy goods vehicle in a scenario where you are limited by mass rather than volume, losing 5 or 6 tons of payload capacity just doesn't work for you.
For the battery, right?
Yeah, for the battery in a battery equivalent. But with the technology that we're developing here, you can have a zero emission truck and it has no weight penalty versus the internal combustion version.
Wow. Now, you're from a motorsport background.
I am.
You mentioned about lots of power and performance. I can't help but notice that.
Yeah,
Can we have a look? Can you
one
show
of
us
our
around?
vehicles. Yeah, for sure. Let's go and have a look
This
around
is a
it.
Radical, right?
Yeah, this was a Radical.
It's not like any Radical I've ever seen before.
Well, the headlights are the same.
Yeah, it kind of looks similar, but it looks like a Radical met Back to the Future.
There's a lot of technology in this. So this is, I know, right? This is a great example of the kind of stuff that we're doing, because we are developing a whole range of technology, a whole range of enabling technologies to allow other companies, other people, other businesses to build fuel cell vehicles, to build hydrogen vehicles. So we use this for power electronics testing, for battery testing, for lots of engineering development purposes. But you're quite right, because of how this is built, it's very modular, so we can put things on it, take things off. It looks crazy, it looks insane.
It's wicked. So the performance stats of this?
About 300 kilowatt deployable, it's about 400 horsepower in normal terms. It weighs 970-ish kilos. As far as we can ascertain, it's the most power dense fuel cell vehicle that anyone's built. And it's a really good example of this mass that we're talking about, because the fuel cell system on this and some other elements of it are unoptimized in terms of mass, but the vehicle's still sub a ton.
So talking about driving, it's only got one seat.
Only one.
I would love to have a drive of this. However, the weather today isn't great, and it's an open top car.
Yeah,
And you said it's got 400 horsepower.
I see where you're going with this.
Yeah. Have you got anything with a roof on it?
Funnily enough.
So this, now I'm a Porsche guy. You're a Porsche guy.
I'm a Porsche guy.
Here we go, is a Porsche.
Yeah.
I get the feeling this isn't a normal Porsche.
It was at one point in its life.
Right, okay.
So when we founded Viratech, in the early days of Viratech, we said very shortly after that point, right, we need a development vehicle. And of course, it was at a point where you couldn't go and buy a fuel cell vehicle, there wasn't one.
Yeah.
So we said, okay, using what is available to us and ignoring really concepts such as, range and vehicle performance, what we want is something that represents the physics of it. Because of the work we're doing around simulation tools and similar, we needed something to validate those tools. We built this.
Yeah.
So this is a fuel cell, hydrogen-powered Cayman.
Wow.
But performance-wise, it's pretty comparable to what the Cayman was originally. The difference is you'll find that the faster the vehicle goes, the more energy you have available to you, because it's a combination of the gearing and the engine calibration and similar.
And I noticed it's on Michelin's. Tell us a bit about how you've been working with Michelin.
So Michelin, we started working with on the Hypercar program, and they were fantastic for us. Their technical support was incredible, because obviously we're looking to deploy incredible amounts of energy in that vehicle very quickly. So there's no ramp in. We can deploy hundreds of newton meters of torque in a split second.
My kind of car.
Your kind of car.
Yeah.
But of course, it does provide a rather unique challenge to tyre as well. So Michelin were amazing, and we've worked with Michelin on a whole raft of things since. So yeah, they are a real key technical partner of ours.
So I can have a drive of this?
Absolutely.
But one of the things about Myra is you've got these amazing roads. It looks quite complicated. Can we go out and have a bit of a sighting lapse? I'm in a Taycan. It's not hydrogen, but if we go out and have a show me round, and then maybe I'll have a go.
More than happy to. Yeah. Let's go.
Fantastic. But yeah, what a Porsche. So for you guys, having this test facility literally on your doorstep, I mean, that's why you're here, but it must be amazing.
It is superb, and it's not just the circuits, the test tracks. We have access to lots of other facilities as well. So there's a couple of climate controlled wind tunnels. We've got some shake rigs, both full vehicle and component level. The facilities at Maya are phenomenal. So if you want to develop a vehicle and you want to develop automotive product, it absolutely is the place to be, and it's why there's so many OEMs and tier ones here.
Yeah. So tell me a little bit about a couple of things I want to talk about. We've had a chat about the fuel cell and applications for that. A lot of people think about that as like a range extender and so on.
Yeah.
In some markets, you're saying, I think that's quite an interesting implementation.
Well, there's several different concepts to how a fuel cell vehicle could or should work. One of them is range extension, so you still carry a large battery and you carry a small fuel cell system, and you activate that fuel cell system to reduce the rate at which that battery is discharging, which is range extension. The other view, and it's one that we tend to follow, is that the ideal way to do it is with a larger, higher output fuel cell system, and that is essentially prime mover in the vast majority of situations. So what that means is that all of the energy to move the vehicle is coming from the fuel cell. There are some interesting things you can do with that concept when it comes to some energy management systems and some power electronics, which is our, or should we say, some of the key focuses that we have that allow you to decouple the vehicle performance from the fuel cell performance. So you may have a 100 kilowatt fuel cell, but you can deploy 300 kilowatts in the wheels of the vehicle or more. So that's
Tell me more about that. So that's deploying the fuel cell and the battery's energy into the drivetrain at the same time.
Exactly, yeah. So what you allow vehicle calibrated, so the guys are actually setting up the vehicle. What you provide to them as the tool set is the ability to determine at any moment in time where that energy is coming from and how much of it. So what that means in short is, let's use a hypercar as an example because it's interesting. If you have 200 kilowatt of fuel cell system in a hypercar, 200 kilowatt isn't really a lot of power for a hypercar if you're fully deploying only from the fuel cell. But if you have a battery system or an energy store that allows you to deploy very large amounts of energy for short periods of time, and we're talking about hundreds of kilowatts a minute, you can use that energy alongside the fuel cell energy. So imagine that you launch on that stored energy at the limit of the tyre traction, so 400 or 500 kilowatts. You then begin to ramp the fuel cell system up, which not only then adds energy, but it also holds up the HV bus voltage of the vehicle, so you have more motor RPM available.
Yeah.
And then as you do your 0 to 200 mile an hour sprint or similar, you end that at full deploy on both systems. And in those scenarios, as we saw with Apricali, the hypercar program that we have, you're deploying 800 kilowatts of energy from 200 kilowatt fuel cell system.
So I'm going to have a drive of the Cayman.
Yes.
Which is very cool. It's not got that much power that you would just hypercar power, but it has got the dual deployment capability.
It's the same energy management system. So the Cayman is actually our sort of physics research tool. We actually used it to validate a lot of our simulation and in the early days of putting our simulation tool sets together. And we also formed the basis of our vehicle control that now runs on both Mule 2 and the other vehicles that you'll see. So yes, the Cayman, really interesting thing for you to drive, has exactly the same energy management that we've just discussed, has a fuel cell, has a small capacity but high C rate capable battery system, and it's using all of those concepts that we've just described in that vehicle.
Best get behind the wheel then.
Please do.
I'm looking forward to it. So here we are in the world's only hydrogen-powered Porsche Cayman. And just chatting to Matt, I'm actually only the second person outside of Viratech to be able to drive this car. So it's a real privilege. The weather conditions are absolutely terrible. But the first thing to know is all the different noises that you get in a fuel cell car. You've got noises in the background when the fuel cell kicks in. I've got a massive, great big kind of DC to DC converter and battery where the passenger would be. And I've got a display in front of me with all kinds of numbers and voltage discharging and stuff. Really, really cool. And we're trucking along pretty good already. I've got squeaky windscreen wipers. Now, I'm not going to be driving this car too hard by any means, but luckily it is on Michelin Pilot Sport 4S tyres, which for this kind of weather conditions is absolutely perfect. The other interesting thing about this fuel cell powered Porsche Cayman is it's actually lighter than the internal combustion engined Porsche Cayman, which I think is really, really cool. So I must say, I found today absolutely fascinating. A completely different look at how hydrogen can be used in a range of different use cases. That 30 to 35% of use cases where battery electric really isn't optimal, isn't the perfect solution. It's been great talking to Matt and the team at Viratech, and hats off to them for the work they do, the ability to innovate at this level, to push the boundaries, to take motorsport knowledge and motorsport engineering into non-motorsport applications, to create cars like this and ultimately high performance cars that look beautiful but have an alternative fuel source. I think that's really exciting for any petrol head. But then to take the same technology and put it into applications like light and heavy goods vehicles. This is why, for me, there's a wider discussion to be had about hydrogen, because it has this versatility. It's just an immature technology. We just need to put the R&D money into it. But this car's brilliant. Thank you for joining me as I explored the future of sustainable mobility and the role that hydrogen has to play in that. It's great to see Michelin partnering with such innovative companies, and I'd like to say a big thank you to everyone at Riversimple and Viratech for showing me what work they're doing. I've certainly enjoyed the last couple of days, and I hope you have too. But for now, take care guys and drive safe.